So in this video I want to talk a little bit about polygons because in the next lesson we're going to be focusing on perimeter, and eventually we'll talk about area pretty soon. And when we're talking about perimeter and area, we're usually referring those types of problems to specific shapes or two-dimensional figures. And so what I want to just clearly specify is that a polygon is a two-dimensional figure, and it's made of line segments, and also it's a closed figure. So in this handout, which I found on the internet, it's an illustration of several kinds of polygons, and notice that they're all made from line segments. There's no curved lines that make up any of these. Now notice as we get to the figures that have more and more sides, it kind of looks like the line segments are smaller and smaller, kind of giving it an illusion that it's rounded, but it's not. They're all made out of line segments. The other thing you want to take note is that they're all closed systems. There's no openings, and I don't know if I have any pictures. Oh, here, I've got some pictures over here, another worksheet I found online. Notice number 5, this is an open figure. There's, it's not a closed system. The other thing is, like I said earlier, with these, it's made up of line segments. Here we have some figures that are not polygon because they're made up of curved lines, like number 6 here. We've got a curved line. Even though it's closed, it's still not a polygon. Here we have like an elongated or an ellipse, like an elongated circle called an ellipse. Here is a circle. That is not a polygon, nor is this one, even though part of the figure has straight lines or line segments. The other part does not. Now, one other thing we want to take note of is that polygons can be both convex and concave. Now, if you think of cave is you're going in a dwelling, and so like number 3, this would be a concave polygon because it kind of goes inward on itself like that. Number 12 is also considered concave. Again, it goes in. If you have polygons that don't go inward, they're called convex. They go out. Okay, all of these lines are moving outward. This is a convex polygon. Here's a convex polygon. These two are convex polygons. Okay, so we want to take note that there's what they're made of. They're made up of line segments, and it's a closed figure, meaning all the line segments meet at a corner, and the corners have a special name called vertex. So for instance, right here, this is a vertex, this is a vertex, 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 vertex. And so let me go ahead and write on here, just to kind of zero in on what we've been talking about. So it's made up of line segments that meet at corners, okay, that meet at corners, which I'm going to say at vertex or vertices. Vertices is the plural of vertex. Vertex is like the corner. Okay, and it's a closed figure. Closed figure, meaning there's no gaps. Okay, so for instance, if I just draw, it kind of looks like a rectangle here. Notice that it's made up of line segments. Okay, these are all lines, and the lines meet at the corners, which are the vertices, or each one is a vertex. Vertex, plural is vertices. And like I said earlier, you can have concave polygons, which is a figure that kind of goes in on itself, like that. Okay, it goes inward, or a convex polygon. And so there's none of this going inward business. It's just all of them are kind of going out. Okay, and they're all closed, and they're all made up of line segments. Now there's one other thing that I want to mention that we want to specify, and that's regular polygons versus irregular polygons. So we've got regular polygons, and let me see if I have a picture. Here's some examples of I'll go to this one here that I had out earlier. All of these are regular polygons, and the reason they're regular there's two reasons why they're regular. They have equal sides, so there's the meaning, not meaning that they all have 3 sides, but that the side lengths are the same dimension. So if we took a ruler and measured each side would be the same amount. And so there's a special word for that. That's called equilateral. And that means equal side lengths. Okay. Now the other thing that they have in common is that they have equal angles. Okay? The angle dimensions are going to be the same, and the special word for that is equal angular. It's hard to say. Oh, excuse me, there's no L. Equiangular. There we go. And that means equal angles. Okay, so you can see this happens to be an equilateral triangle, meaning the angles are equal and the sides are equal, and each angle is going to be 60 degrees. I know that because the sum of the interior angles, if we were to add up all these angles of a triangle, all triangles have the sum of 180 degrees. So if I were to divide that by 3, each of these angles would be 60 degrees. Same with this square. This square is a regular polygon. It has equal side dimensions. They're all going to be the same, but also each corner or each angle is going to be 90 degrees. And I know that because I could take a protractor and measure it, but also the interior angles of a square are going to equal 360. Anyway, that's something I just know, and I'm just sharing that with you. But just to prove a point that these are all regular polygons because they have equal side dimensions and equal angles. Interior angles is what I'm talking about here. Okay, now irregular polygons, we'll go ahead and write that here, irregular polygons. Now, IR, that's going to mean not regular. That's basically what that's saying, not regular. So irregular means that, we're still going to have a polygon. We're still going to have, a 2-dimensional figure made up of line segments that meet at the vertices, and it's still going to be a closed figure. But they're not going to necessarily have equal sides or equal angles. And so we might have something that, here's some examples here. So in this case we have a triangle. This would be a regular triangle, but notice in this irregular triangle the side lengths are clearly not the same, and then the angles of course are not going to be the same. Now you can have some triangles that in which you have 2 of the sides, 2 of the 3 sides are equal, or 2 of the angles are equal, but that third side or that third angle is not equal, and that still would make it irregular. Here we have a square. Now a square is a type of polygon called a quadrilateral, quad meaning 4. And here we have another quadrilateral. Notice 4 unequal sides. That you can kind of see the angles are not going to be the same. They're not equal. Here we have a pentagon, penta meaning 5. We've got 5 sides, 5 equal angles. We still have 5 sides here, 1, 2, 3, 4, 5, but you could clearly see that we don't have equal lengths for our side dimensions, and so on. So, hexagon is for 6-sided. This is a regular hexagon. Here's an irregular hexagon, which happens to be concave, by the way. Octagon has 8 sides, 8 angles, and then here we have another concave irregular octagon. So anyway, there's many more, but these are just some good examples of what I'm referring to when I'm talking about polygons. The main things that you want to focus on are these two things here. What is a polygon? Well, this kind of explains what a polygon is. And then we've got different kinds of polygons, and mainly we've got regular polygons, and we have irregular polygons. And then how the polygons are shaped is going to be important. You're going to have the concave and the convex. Okay, well, in the next videos, when I talk about area and perimeter, I'm going to be referring to polygons, and so I just wanted to give you a heads up on what all that was about. Again, if you have questions, bring them to class and we'll talk more about it.